Hello everyone. In this section, we will discuss the difference between CNN and RNN. So we have already discussed about the CNN RNN implementation. Now we will discuss the difference. So in the following given table of content, first we will discuss the difference between CNN and RNN. After that, we will implement the implementation of CNN and RNN. So first we will discuss the CNN and RNN difference. So basically the main difference between a CNN and RNN is the ability to process the information data that comes in sequence, such as a sentence. While in the case of recurrent neural network are designed for this purpose, while CNN are incapable of effectively interpreting information. In CNN, convolution occurs between two matrices to generate a third output matrix. A matrix is known as an array of elements that contains columns and rows. So CNN utilizes the convolution in the layers to divide the input informations and find the actual one. Now the following given table we will discuss the difference between the CNN and RNN by using TensorFlow. So first point is CNN is more powerful than RNN because CNN use of connectivity patterns between neurons, and CNN is affected by the organizations of the animal visual whose individual neurons are arranged in such a way that they can respond to overlapping region in the visual field. While in the case of RNN, RNN includes less feature compatibility when compared to CNN, and also it uses time series information in which a user spoke last would impact RNN. Basically, CNN is used for computer vision application, and it is a class of deep neural networks that are used to analyze visual imagery. While in the case of RNN, they are a class of neural networks that allow previous output which are to be used as inputs while having hidden state. So this network takes fixed size inputs and generate fixed size outputs, because the purpose of the convolution is to extract the feature of the object on the image locally. That means the network will learn specific patterns within the picture and will be able to recognize them everywhere in the picture. So RNN can handle arbitrary input output lengths, and also RNN is used in time series prediction, image captioning, natural language processing, sentimental analysis, and machine translation. So during the convolutional layer, the network keeps the necessary feature of the image and excludes irrelevant noise. If you use a traditional neural network, the model will assign a weight to all the pixels, which is not essential for the network. While in the case of RNN, it cannot handle sequential data and considers only the current input and cannot memorize previous input. Also, the main purpose of the convolutional is to fetch the feature of the object on the image. So in simple words, we can say that convolutional means element-wise multiplication. In the case of RNN, it is quite difficult to propagate all this information when the time step is too large. When a network has extra deep layers, then it becomes untrainable. So this problem is known as the vanishing gradient problem, because the gradients grow smaller when the network progresses down to the lower layer. So convolutional neural network are ideal for images and video processing, while in the case of recurrent neural network are ideal for text and speech analysis. So CNN is a type of feed-forward artificial neural network with variation of multi-layer perception designed to use minimal amount of pre-processing. While in the case of RNN unlike feed-forward neural networks, and it can use their internal memory to process arbitrary sequence of input. Now let us take an example and understand the difference between convolutional and recurrent neural network. So here is the example. In this example, first we have imported the necessary libraries. After that, we have used the MNIST data set. For this, we have used the from TensorFlow.keras import layers library, and in this example we have images, and the images shape are 28, 28 pixels, and now we will treat as a sequence So this means our input size and the sequence length is also 28, 28. So this means we have 28 time steps in our sequence, and in each time step we have 28 features. Now we simply use the RNN model. For this we have defined a sequential model by using keras.models.sequential, and the first thing we have done is to be added an input, that is model.add, and within this we have specified the shape, that is 28, 28, and this represented as a sequence length and the input size. After that we have added the RNN model, that is simple RNN. So within this we have specified the number of units, that is 128, and this is also the size of a hidden layer, and by default the activation function is tanH, but in this case we are using the ReLU function. Now next we must do a classification. So we have a 10 different classes in the MNIST data set, and then we have added a dense layer in the model.add, and we want to get the 10 output. Next we display the summary of the sequential model. So as you can see that the dense layer output has 10 and the shape of the image is 28. So after that we have used the loss function by using keras.losses.categorical cross entropy function, and within this we have set the from logits equals to true, and next we have defined the batch value size, that is 64, and set the approach value, that is 5. After that we have evaluate the training part. For this we have used the model.evaluate. So after using the RNN model we have used the convolutional model, that is CONV2D, and mention the shape of the image, that is 32, 32, 3. And also in this example we have used the MNIST load data set we have already taken in the RNN model. So we have set the activation function, that is ReLU dense layer, to displaying the summary of a model. It shows the convo2D shape, that is 30, 30, 32. So with this we have completed the implementation of CNN and RNN.